For these problems, we want to work with what we've done previously with trigonometry and review over those ideas in order to use them now in the context of these word problems. So we're going to start with the demo problem, and then we'll have you pause, work with a group to work on the participation problem, and then come back and you can look at that one as well. So first of all, what we're going to use for these problems is we've used this phrase, so ka toa, in order to help us remember sine, cosine, and tangent, which parts of right triangles we use. So we'll use that in this problem. The first problem here is a plane is flying at an altitude of 12,000 meters. From the pilot, the angle of depression to the airport is 32 degrees. How far away is the tower from the point directly below the plane? So it's important that when you do a problem like this that you draw a diagram, just so you're getting things in the right place. So if we've got a plane up here, I'll put P for plane, and then down here we've got the airport tower. I'm just going to put A for airport tower. And so the angle of depression, well, first of all, the plane is flying at an altitude of 12,000 meters. So that's how high up the plane is. Now it says the angle of depression from the airport to from the plane to the airport tower is 32 degrees. Now just recall, when you do an angle of depression, it's from looking straight out and then going down with that angle. So the angle down to the airport tower, this is the 32 degrees. The mistake people will make is put it here instead. Be careful about that. The angle is here, and what we can do now is there's two ways to do this problem. What we want to find is how far this distance is, the airport tower from the point directly below the plane. So this is our x that we're trying to find. Now when we do this, we want to recognize we've got alternate interior angles. You can use this angle as 32 degrees also. So I'm going to use this right triangle. It's probably the easiest way to do it. You could also draw this line here and use that this is a rectangle and get sides to use for doing the problem as well. So first of all, I'm going to do on this one, I've got this angle. I've got the opposite side and the adjacent side. So the opposite and adjacent side are involved in the problem. That's tangent. So tangent of 32 degrees is equal to the opposite, which is 12,000, over the x I'm trying to find. Now to solve this problem, you want to go ahead and get the x out of the denominator. We do that by multiplying both sides by x. Once we've done that, then we've got x times tangent of 32 degrees equal to 12,000. Now you want to get the x by itself, so you divide both sides by tangent of 32 degrees. So you've got x equal to 12,000 divided by tangent of 32 degrees. We can do that on our calculator. When we do that on our calculator, we get x equal to 19,204 meters for our answer. So when we do this problem, just remember, drawing a diagram is really important for getting the right information, then using the correct trig function, and then solving the equation from there. Now it's time to pause the video, go ahead and with your partners work on this problem down here, this participation problem. Try that with your partners and then come back and see how the problem is solved to check your work. Now that we're back into the video, let's go ahead and work on this problem, see how you did with your group. So it says Mando looks up at the sky at an angle of elevation of 65 degrees. The TIE fighter is at an altitude of 3,100 glics. Now, glics is a made-up unit, but the idea is whatever the measurement unit is, we've got to use that measurement. So this would be in a land far, far away, maybe what they use as their unit of measure, 3,100 glics, then find out how far the TIE fighter is from Mando. If the TIE fighter is approaching at 820 glics per minute, how long does it take Mando to hide before the TIE fighter gets to his location? So we've got two problems. We want to find out how far the TIE fighter is. So if this is Mando down here, and this is the TIE fighter, I'll just put M and T there. And so it says the angle of elevation is 65 degrees. So from straight out, looking up at the TIE fighter, here's our triangle, this angle is 65 degrees. Now notice, I've not drawn it especially proportional to that. 65 would be a little bit bigger than that, but you don't need to, you just need to get the information into the triangle. All right, now it says that the TIE fighter's at an altitude of 3,100 Glicks. We want to know how far the TIE fighter is from Mando. Now this is the actual distance between the two, so I'm going to call this D for distance between Mando and the TIE fighter. Let's find that first. Now, when we look at the information given, we have an angle, the opposite side, and the hypotenuse. The trig function that has opposite and hypotenuse is sine. So I'm going to use sine of 65 degrees equals 3,100 over D. Okay? Now again, how I got sine is using my SOHCAHTOA, opposite and hypotenuse, that goes with sine. So you got to pick the correct trig function when you do this. Now we want to get the D out of the denominator, so we multiply by D on both sides. So we have D times sine of 65 degrees is equal to 3,100, because the D's reduce out. Now we go ahead and divide by sine of 65 on both sides. So we get 3,100 divided by sine of 65 is what D is equal to. Now I can calculate that on my calculator, and I got that it is 3,420. Now, 3,420, what's the unit of measure? It was this made up measurement of a place far away is Glicks. So I want to put down that this is 3,420 Glicks. That's how far. That's the answer to the first question. Now the second question is, if the TIE fighter is approaching at 820 Glicks per minute, here's a speed, okay? Then how long does it take Mando to have to hide before it gets to the TIE fighter? Just a reminder, we have the formula that we've used many times in mathematics, rate times time equals distance. R times T equals D. So I'm gonna just write out the words, rate times time equals distance. We're going to use this formula, and in this case, the distance that we have is 3,420 Glicks. So we're going to take the rate, which we have as 820, so 820 times the time, which we don't know, that's what we're trying to solve for, so time equals 3,420 Glicks. Now, how you get T by itself is you divide by 820. So you divide by 3,420 by 820, and you get about, we're going to estimate this one, I'm going to round to the nearest minute. This is about 4 minutes, okay? Now, how do I get minutes? Notice that the unit it uses is Glicks per minute, so I know my time element is minutes, so my answer is 4 minutes, approximately. Depends on what you're asked to round to. So in this problem, again, we drew a picture. From the picture, we selected the correct trig function, and then we did our algebra to solve for the distance between the two, which this happened to be the hypotenuse because of the fact that it was saying the distance between the two of them. And then we went ahead and found out the answer after that for time using rate times time equals distance.